Hello everyone, my name is Dominic Intriago and I'm a part of Dr. G's General Chemistry 1 laboratory class at Palm Beach State College. Today I'm going to go ahead and show you how to do experiment 5 and I'm going to show you all the calculations for finding the empirical formula. As you can see, the two elements that we're going to be working with today is going to be iron and chlorine. We're going to be working with 2.538 grams of iron and with 4.712 grams of chlorine. And just so you know, the compound that we're going to eventually get at the end is going to be iron chloride. To calculate the empirical formula, we are going to be using this formula. So it's going to be the mass of the element times 1 mole of the element divided by the atomic mass of the same element. So our first step in calculating the empirical formula is finding out how many moles of iron we're going to have. So 2.538 grams of iron times 1 mole of iron divided by 55.845 grams of iron, which is the atomic mass, and you can find this in the periodic table. That's where I got it from. Now, since we have two opposite sides of the fraction, and then we have grams of iron on the top left side and also grams of iron on the bottom right side, we are just going to go ahead and cancel those out, and that's going to be equal to 2.538 moles of iron divided by 55.845. And that is going to be equal to 0.4544722 moles of iron, but we're going to go ahead and round that up to 4 decimal places, so we have left 0.0454 moles of iron. The second step is finding out how many moles of chlorine we have, so we're going to do 4.712 grams of chlorine times 1 mole of chlorine and divided by 35.453 grams of chlorine, which again is the atomic mass. And just like we did right above, the grams of chlorine are going to be cancelled, and then we have left 4.712 moles of chlorine divided by 35.453. And then that is going to be equal to 0.1329086 moles of chlorine, and just like we did above, we're going to round up to 4 decimal places, so we have left 0.1329 moles of chlorine. Now the third step is going to identify which of the elements we have less of according to moles, and then we're going to divide the number that we already have for each element as far as moles go, and we're going to divide by the lowest number. So in this case 0.0454 is the lowest, so we're going to divide that by whichever number of moles we have for each element. So that means 0.045 is going to be divided by 0.045, giving us 1 mole of iron, and then 0.1329 is going to be divided by 0.0454, giving us 2.9, but we're going to run that up to 3 moles of chlorine, and we have 1 mole of iron and 3 moles of chlorine, and this is going to help us write our formula of the compound. And now, since we have found our ratio for our compound, we're going to go ahead and write it down. So it's going to be Fe iron with 1 mole, and then we have our chlorine with 3 moles, making it iron chloride, making our final answer FeCl3. Thank you so much for watching, and I hope this was helpful for experiment 5.